Okay, item 16 to 20 will challenge you to draw the free body diagram of the object shown in the figure rather. So we have an object and it is hanging by a ceiling um, through the use of let's say cables or ropes. So how will we draw the free body diagram for this object? So of course the object has a mass, obviously, so we expect that there will be a gravitational force, and it is hanging on the ceiling because there is an upward force lifting it, so it can hang mid-air. That would be the tension. So the free body diagram of the box will look like this. But you can also account for the tensions T1 and T2. T1 has an angle from the ceiling equal to 60, while T2 has an angle from the ceiling equal to 40 Newton. So you can also account for that, T1 and T2. For item 17, we have an object with a mass of 10 kilogram getting pulled using a string wrapped around a pulley. So how will we draw the free body diagram? So already we know that it's resting on a surface, right? So we expect that there will be normal force. Of course, it has a mass, so gravitational force will also be present. So we have normal force and we have gravitational force. Okay, so the trouble here is, where do I draw the tension, or where do I draw the applied force here? Do I draw it to the right, or is it directed to the right or to the left? So we can see that the string is attached to the left side of the box. That's why the applied force is directed to the left as well. The applied force will be the one responsible for moving the box to the left. And since it's moving to the left, the frictional force will be opposite of that direction. The frictional force will be to the right. Okay, so on item 18, we have two masses, object B and object A. So object A is smaller and it is on top of object B. Object A is also attached to a string, let's say, on its right side. It's attached to the wall through a string on its right side. Meanwhile, object B is getting pulled to the left. There's an applied force on object B. So how are the forces on the two masses, A and B, interacting? Or what are those forces present on both of them? So I have to draw a free body diagram for both of the objects. So I guess we need to draw the FBD for object A first. So it has a mass, obviously. So it has a gravitational force downward as well, always downwards. Since it is resting on the object B, or it is on top of object B, it is object B experiencing that weight. As a reaction, it will exert an upward normal force on object A, which you can see here. There is a string on its right side, so the tension should be to the right. When you pull the object B, object A will go along with object B, but it cannot move very far since it is attached to the wall through the string. Okay, through the string. So it's also moving to the left, but there's a limitation to its movement since there is a string not allowing it to, let's say, to ride on object B to the left. So since it's moving along with object B to the left, there's a frictional force to the right. And what is that force pulling it to the right together with object B? That is the force of object B exerted on box A, on object A. Okay, so you will just do this labeling. Force on um, box A, on A right here, due to or exerted by box B. Okay, since box B is getting pulled to the left. So force exerted by box B on box A. That's the notation. How about box B? So the same, there is a gravitational force on box B since it has a mass, and there's a normal force exerted by the floor on box B. But the normal force on box B is larger than the one on box A, since this is a reaction, or this is the reaction of the surface or of the floor on the combined mass of box A and B. So that's why here on the weight here, on the FG here, I put A plus B. Okay? Since the normal force exerted on box B is a result of the combined masses or the combined weight of A and B. So it's getting pulled to the left, so your applied force is to the left, of course. So you would expect that the frictional force is opposite of that. And since object B is acting on object A, there's a force exerted on box A due to box B. In the same way, on box B, there will be a force exerted by box A. So, force exerted by box A on box B. Same magnitude but opposite in direction. Okay? Okay, on item number 19, we have a pulley system here. We have also a ramp. On the ramp is mass 1, while mass 1 is attached to mass 2 or to mass 2 by means of a string, and mass 2 is hanging. So I guess it's easier to do a free body diagram for mass 2. Essentially, it looks like the one with the elevator, right? So we have a tension, the force responsible for keeping it hanging. Opposite in direction is the force of the weight, or the force of the gravitational force, the gravitational pull of the Earth on this particular object. Okay, mass 1 is on an incline or on a ramp. Of course, there is also a tension force, the same tension force as in mass 2, since it is the same string connecting the two of them, right? Let us say that mass 2 is accelerating downward, and it is pulling mass 1 upwards. That's why the frictional force right here is to the left, or downwards the incline, since the tension here is accelerating mass 1 upward the incline. So the frictional force will be opposite that. Gravitational force is always straight downwards, although or even if the mass is on an incline, but the normal force will always be perpendicular to the surface. So that's why it looks like this. Okay, so for the final item, you are to draw the free body diagram of two masses, mass 1 and 2, both of them on a ramp, and they are connected through the means of a string or a rope. So let's do first mass 1. So mass 1, again, we have a tension here, so it's getting pulled downwards by mass 2 by means of this tension or this tensile force. Since we assume that it's accelerating downward, it's moving downward, we have a frictional force due to the interaction of the molecules of the bottom of this mass 1 with the surface of the ramp. Okay, so opposite of the motion is the frictional direction of the motion is the direction of the frictional force. Again, as a while ago, gravitational force will be straight downwards, and the normal force will be perpendicular with the surface. Mass 2, okay, the same. We have the normal force and the gravitational force. The tension here, it's getting pulled upward by mass 2. Okay, so the tension on mass 1 is the same tension present on mass 2. So since it's pulling mass 1 with it, it's slowing its acceleration. Ano po? And you can see that here, due to caused by the tension or being pulled by mass 1, by the weight of mass 1. Since mass 2 is also moving downwards, down the incline, frictional force is opposite that. So upwards frictional force. Okay, so that's it for our problem set. I hope you were able to answer it. Good luck with your exams.